Hello everyone and welcome to lesson 10.1.1. Welcome to the final chapter dealing with surface area and volume. So we're going to start off by talking about cube roots. How long is the side? And before we can really talk about cube roots, the three-dimensional object you can see on your screen right here, we need to remind ourselves of two dimension. See, previously we dealt with square roots. And a square root radical looked like this. There was an invisible 2 right there. Mathematicians are lazy, and so they leave that 2 out. And when we were doing this, we were thinking, what times what is 40? And the reason why we have square roots is because there is no perfect number that is exactly this number. Now, if I were to approximate this, it's going to be somewhere around like 6.3 times 6.3, but there's no rational number that is exactly 40. And we use the square root symbol to deal with these irrational numbers. And so in today's lesson, what we're going to be working towards is gaining an understanding of what cubes in terms of volume driving forward and cubes in terms of surface area so that we can really develop this chapter. So problem 10-1, using the cube at right as a model, work with your team to create two problem situations that would require knowing the surface area of the cube, then make another two problem situations that would require knowing the volume of the cube. So you need to come up with two situations for surface area, and you need to come up with two situations for volume. Okay, go ahead and pause the video to come up with those two situations. Pause now. Okay, problem number 10-2. Now, problem 10-2, volume is figuring out how much is inside the box. Now, in a cube, if you know one side, you know all three sides. So to find the volume, we are going to do 3 times 3 times 3. And you can do that in your head, and we get 27 feet cubed. Okay? Surface area. To find the surface area, you need to find the area of one face. If you know one side, you know all the sides, but we only need to pay attention to a two-dimensional side here. 3 times 3 gives me an area of 9. And then you have to ask yourself, okay, how many faces are there? Remember a die, like when you're playing a dice game. Okay, so how many numbers are on a die? Well, there are 6. And therefore, I can do the 3 times 3, which was the area, that's a terrible 3, times 6 sides. 3 times 3 is 9, times 6 is 54. Notice this is feet squared. Okay, feet squared. Okay, problem 10-3. Instead of this problem being 3 feet, what if I change this to 5 feet? Go ahead and calculate the volume and calculate the surface area if the side length is now 5. Pause the video to calculate. All right, welcome back. Let's go ahead and dive into problem 10-4. Now reverse the process. If you know the volume, how long is the side? Given the volumes of different cubes below, work with your team to find the length of each side. So you are thinking what times what times what is 8? You are repeating this thinking for A, B, and C. Pause the video to calculate A, B, and C. All right, welcome back. If you were looking at 40, you probably found that there is no number for 40. 2 times 2 times 2 is, excuse me, I wanted 3. 3 times 3 times 3 is 27. And 4 times 4 times 4 is 64. But there's no number for 40. So what you have to do is estimate. Well, you can estimate it, or on a calculator, there is a cube root key. Now, on the calculators that I use here in my classroom, there is a key that looks like this. This is called the caret, okay? Now, you use the caret if you were trying to do 3 to the third power. On a calculator, that would look like this, 3 caret 3. If you're doing 5 to the third power, that would look like this, 5 caret 3. Now on my calculators, there's another button that is just above it in yellow, X root. Not the square root, it is the X root. And the way that we access this cube root is we start on our calculator by typing the number 3, typing in the X root, and then typing in our number. In this case, the number is 40. This on our calculator says the cube root of 40. And when you type that in, that is going to give you an answer that is somewhere between, I believe the answer is 3.41. But I want you to verify that on your calculator. Now, in problem 10-5, did you find the solution by guessing and checking? Well, you should have in A, B, and C, yes. Or did you find a special key on your calculator that helped? Well, it's both. You started with guess and check. You're writing the sentence. We started with guess and check. Then Mr. McCoy showed us the special key. Problem 10-6. If S is the side length of a cube, then S to the third power, or S cubed, represents the volume of the cube. Go ahead and write S cubed. If the volume of the cube is 64 cubic units, write an equation using S, stating that the volume is 64. Well, if the volume is S cubed, and the volume is 64, that is how we write an equation stating the volume is 64 cubic units. Let's hop into problem 10-7. In chapter 9, you solved equations with squares, such as x squared equals 16 by using the square root operation. To solve equations with cubes, such as x cubed equals 64, you need an operation that undoes cubing. You need the operation called cube root. It uses the symbol cube root. Find the cube root key on your calculator, which I showed you in a previous problem. Different calculators perform this operation in different ways, so figure out how to do this on your calculator, then find the cube root of 64 to get the solution to x to the third power equals 64. Here's what I want you to write. On your paper, write x3 equals 64. And then underneath it, you are going to write x equals a number. You need that key on your calculator to do the cube root. You have to type the number 3, then the x root, and then your number. That will give you the side length. Problem 10-8. If you have not already done so, use the cube root key on your calculator to check your answers for problem 10-4. When you have checked your answers, you can simply write done. Last problem, 10-9. Just like with perfect squares and square roots, cube roots of perfect cubes are positive integers. Some of them are listed below. The cube root of 0 is 0, cube root of 1 is 1, cube root of 8 is 2, cube root of 27 is 3, cube root of 64 is 4, cube root of 125 is 5, cube root of 216 is 6. Cube roots of non-perfect cubes, like the cube root of 40, hey, we did that one. I was right, it was 3.4, are irrational numbers. Notice there is no pattern. It should have a ... right there to show that it goes on forever. Without a calculator, you can approximate cube roots to be between consecutive integers as you did with square roots. Look at the example below. I know that the the cube root of 40 is between 27 and 64. Therefore, it is between 3 and 4. That's what they wrote. Approximate each of the following cube roots between consecutive integers. Write each answer in the same way as the example above. So here's what I want you to start by doing. Start by writing the cube root twice. The cube root of 10 is between. The cube root of 10 is between. So what we're going to do is we're going to look at our number line up above and we're going to decide, where is this number? Well, I know the number 10 is between here and here, because 10 is between 8 and 27. So I'm going to go ahead and record that on my paper. It's between the cube root of 8 and the cube root of 27. Notice 10 is between 8 and 27. So if it's between the cube root of 8 and between the cube root of 27, I know that the cube root of 10 is between 2 and 3. Big picture, guys, I need you to know, when I give you a cube root, how much are we talking here? The primary place where people in our area use cube root and volume is dealing with water. Whether you're a farmer figuring out how many cubic feet you have to water your field, how much water is coming out of Oroville Lake, figure out how much concrete you need to pour a sidewalk. These are areas where we typically find volume, okay? I would like you to please pause the video to find the cube roots of the last 3 problems. When you are done, thank you for coming to lesson 10.1.1. Please stay on top of your homework, and we'll see you next time.